So we are going to solve another problem today. So it's 550 division 3 and its rating is 1700. It's posted by a dash again, right? So let's begin. So as always, we are going to explain the example here. So let's take a look at the example. So in the example, it gives us a tree, right? So there are 6 nodes in the tree. And it's not necessarily a tree, it's a graph. And there are 5 edges in the graph. So the node 1 pointed to node 5, right? And the node 2 pointed to node 1, right? And the node 1 pointed to node 4. Node 3 pointed to node 1. Node 6 pointed to node 1, right? And what's the output here? So we need to construct, we need to redirect these edges, right? And to make sure that there are no paths that exceed the length of 2, right? For example, if we take these edges 3 to 1 and we can find a path at 3 to 1 and 1 to 4. So that's a path has a length greater than 1, right? So we should redirect these edges to make sure that don't happen, right? So how do we do that? We just need to, let's take a look at the output here. So we need to keep 1 to 5, 1 to 5, right? To keep this edge and reverse 2 to 1. So reverse this edge. So it becomes like this, right? And this edge is removed. And keep this edge 1 to 4, right? This guy is okay. And reverse this edge 3 to 1. So we reverse this edge into this one, right? And reverse the last edge 6 to 1. So this edge is removed, become like this. So we erase the removed edges, right? And what do we got? So we get a graph like this, and we cannot find a path in this graph which has a length greater than 1, right? So all of the paths in this graph equals to 1, right? So this graph is good, so we output it. So how do we solve this problem? It's quite easy if you find the pattern, right? So let's take a example like this guy. So for this guy, no matter how we arrange the edges here, we always got a path greater than 1, right? For example, this path is greater than 1. And if we reverse it, this path is greater than 1. So for this graph, you cannot find the output. So you just need to output a no here, right? So how do we solve this problem? So let's take another example. Um, this problem is like a coloring problem, right? So when you redirect these edges, we need to make sure that for each node here, either this node has all out degrees, right? So this kind of node is only has out degrees. So it only has edges that comes out of that node. And for another kind of node, they only have in degrees. So they only has edges that come into that node. If we can make sure of that, we can make sure that there is no edge, there is no path bigger than 2, right? Because once edge comes into a node, it stops here because all of the edge for this node are coming in, are in degrees, right? So they stop here. And when some edge comes out of a node, all of those edges connected to this node are coming out of that node, right? So in this way, all of the paths length is just 1, right? So we transform um, this problem into a problem that we can just coloring. We can just color all these nodes, and if the color is black, then this node only has outer degrees, right? So we have 2 black nodes here, and if the node is white, we only has in degrees for these white nodes, right? And if we find a node that should be both white and black, then we find a contradiction. In that case, we need to output no here, right? So let's, how do we color this graph? We just need to DFS search, right? Like, for example, we can start from any node and color it into white, right? So this guy is white, and we DFS to this node. This node should be black, right? Because we need to color the node in a way that that the black and white occurs interceptedly, right? And we go further, find this node. This node should be white. And go further, this node should be black. And go further, we find that this node already colored white, and we want to color this node white. So find no contradiction here. So we just output the answer, right? And let's take a look at this example, right? So we start from here. This node should be white, and DFS to this node should be black, and to this node should be white, and to this node should be black, but it is already colored in white, so that's contradictory, right? So we output a no in this case, right? So I guess that's the way we solve this problem. Let's take a look at the code here, right? This is the main function, and you will read the n and the m, and also read all those edges, right? So these are the edges, and these are the edges for each node. And we do a DFS on any of the nodes. So we choose 1 here, right? And here is where we DFS. So if the node is already colored, and we just need to make sure that the current color we are using is the same color it's colored before. So if it is not, we just need to output no, right? We set valid to false and we output no here. And if it is not colored already, we just need to use the current color to color this node. And the next node, we choose a different color and we do the DFS further, right? And after we do color all those nodes, we just need to output the states for all of the edges, right? This is where we iterate all of those edges in the input, right? And for each edge, if we find the starting point of the node is colored in white, then we output 1. We keep it, right? And if we find out that the color is black, then we reverse it, right? So that's the output here. So I guess that's it for this problem. Hopefully it can help you to understand this problem better. So thank you for watching.